Okay, in this lesson we'll talk about reflections. Reflections are a type of transformation. And remember, a transformation is when the figure changes, either changes location, changes shape, or changes size. There are four main types of transformations. We have translations, reflections, rotations, and dilations. In this lesson we'll be focusing on reflections. Reflections are a flip. We are flipping the image across what is called the line of reflection. Here are some properties of reflections. Reflections preserve the size of the figure, they preserve the shape of the figure, but not the orientation. It will look different after it is reflected. The image and the pre-image are mirrors. When something is reflected across the line of reflection, it's mirrored. And in reflections, corresponding sides are congruent, and the corresponding angles are congruent, which makes the image and the pre-image congruent. Finally, the corresponding points are the same distance from the line of reflection, and we'll see that in the examples that we'll do. We'll do 4 examples. Here's example number 1. Okay, I have this image, and I want to reflect this image over the x-axis. Now remember, this is the x-axis, this is the y-axis. Okay, so what I need to do is I can count how far away each of these points are and reflect it over the x-axis. So it's as if I'm going to fold my paper over the x-axis, and that's where my image will be. This is the pre-image, so we'll start with point A. Point A, how far away is it from the x-axis? Well, it is 1, 2, 3, 4 away from the x-axis, so if I flip it over, it's going to also be 1, 2, 3, 4 away from the x-axis. I can call this A prime. This is A prime. B, point B is 1, 2, 3 away from the x-axis, so if I flip it over the x-axis, it's 1, 2, 3 away. This is B prime. And C is 1 space away, so when you flip it over, it's 1 space away from the x-axis, so that is C prime. If I just connect the dots there, this is my image. I'm going to shade it in to show this is the new image. This is the image reflected over the x-axis. Now, to show this algebraically, what we're doing here is when we're reflecting over the x-axis, the xy ordered pair, write this in a different color, the xy ordered pair becomes x negative y. You are changing the y coordinate. We change y. Okay, so if we go through and look at each one of these, like A was negative 2, 4. So if we change the y, it's negative 2, negative 4, and that's where A prime is. For B, the point was 2, 3. So if we change y to negative, it becomes 2, negative 3. That's the order pair for B prime. And then for C, C was at negative 1, 1. And so if you change the y, it becomes negative 1, negative 1. And that's where C prime is. Example number 2, we're going to reflect over the y-axis. So here is our figure, our triangle ABC, and we want to reflect this over the y-axis. So remember, this is x, this is y, and so I'm going to basically flip it over into this side over the y-axis. So again, I can count to see how many spaces away is A away from the y-axis. Well, it's 1. So if I flip it over on this side, this right here would be A prime. This is A prime. B, how far away is B away from the y-axis? It's 1, 2. And so if you flip it over, it's 1, 2 away. This is B prime. And then for C, C is 1, 2, 3, 4, 5 away from the y-axis. And so if you flip it over, it's also 1, 2, 3, 4, 5 away. This would be C prime. And so this is the triangle. I'll show that it's the image by shading it in. That's the image reflected over the y-axis. Now, how can we represent this algebraically? Well, if you're reflecting over the y-axis, your x, y ordered pair will become negative x, y. Okay, so this is just the opposite of reflecting over the x-axis. If you reflect over the y-axis, we change x. We change, spelled change wrong. We change the x to its negative. And so here, if A is at 1, 7, A prime would be at negative 1, 7. That's the order pair for A prime, negative 1, 7. For B, if B was at 2, 3, then B prime is at negative 2, 3. And if C is at 5, 2, C prime is at negative 5, 2. Okay, so that's how we represent this algebraically when we reflect over the y-axis. Example 3, we're going to reflect not over the x or y-axis, but over x equals 1, because we can reflect over any line. It doesn't have to be the x-axis or the y-axis. We can reflect over any line. And so here we're going to reflect over x equals 1. We have triangle RST. The first thing to establish is, where is this line, x equals 1? Remember, if you have x equals something, that is a vertical line. And so if this is the x coordinate 1 right here, I have a vertical line, an up and down line, on 1. Okay, so this red line right here, pretend it's straight. This is our line of reflection. We want to reflect this triangle over that line. Okay, so let's count how many spaces is R away from this line of reflection. Well, it's 1, 2 away. So when you reflect over this line, it's going to be 1, 2 away from the line of reflection. So this is R prime. For S, how far is S away from the line of reflection? Well, it's 1, 2, 3 away, and so on the other side, it's 1, 2, 3 away from the line of reflection. This is S prime. And then we have T. T is only 1 away, 1 unit away from the line of reflection, so if you reflect it over, it's going to be right here, right on the y-axis. This is T prime. Okay, so if you connect the dots right here, this is your triangle. I'll shade it in. This is the image, right? That triangle is reflected over x equals 1, and so this is our image. And the last example, example number 4, this is, we're going to reflect over y equals negative 2. So we've reflected over the x-axis, the y-axis, and we've reflected over a vertical line. Well, this is reflecting over a horizontal line, because if you have y equals something, that is a horizontal line on negative 2. So this right here, negative 2, we have a horizontal line. We are going to reflect this triangle, ABC, over that line. Okay, so let's count and see. How far is A away from the line of reflection? It's 1 away, and so it will be 1 away on this side. This will be A prime. How far is B away from the line of reflection? It's 1, 2 away. So on this side, it's 1, 2 away. This is B prime. What about C? C is 1, 2 away, and so on this side, it will be 1, 2 away. This would be C prime. If you connect it, this would be the triangle. Shade that in. That is my image reflected over y equals negative 2.